Welcome to 2.3 Deductive Reasoning. Deductive reasoning, let's just get right into it. What is it? It uses facts, rules, definitions, or properties. This is all in your notes here, by the way, so make sure you're getting these in your notes. Feel free to pause the video if you don't have enough time, but we're using these four things to reach logical conclusions. All right, now, there's a lot of similarity here between deductive and inductive reasoning, because with inductive reasoning, that uses a number of specific examples or patterns to arrive at conclusions. Okay, so oftentimes we'll formulate a rule from a pattern, right? So that's where this gets a little bit confusing. But if you're following a pattern or an example over and over and over again, we're using inductive reasoning. But if there's a rule of some sort, then we're going to be using deductive reasoning. Okay, so hopefully by the end of this, you'll get the difference between the two. Let's look at example 1. It says all of the signature items on the restaurant's menu shown. Okay, so there's a picture in your textbook, and there's like, I don't know, some kind of special star or something next to signature items. They have a special symbol. Kevin orders a menu item that has this symbol, okay, next to it, so he concludes that the menu item that he has ordered is a signature item. So we're trying to figure out, is this a pattern here, which kind of looks like a pattern because it's the same whatever symbol next to the signature items, but it's not necessarily like a pattern that we're using to follow. This is more of like a definition or a rule. When they made the menu, they put a symbol next to it to define the signature items, right? So if it has that symbol, it's a signature item. That's just part of the definition of the menu item. So that would be considered a deductive reasoning. Now, on the flip side of this, let's say that Raul goes to the restaurant on a Thursday. Every time he goes on a Thursday, that there's a certain special, like a cheese supreme is the special. So if Raul goes to the restaurant on a Thursday, he concludes that cheese supreme will be the special. Okay, in this particular case, it would be inductive reasoning because he's following this pattern. Every time I go on a Thursday, this is what I see. Every Thursday, this is what I see. Every Thursday, this is what I see. It's that pattern that he would use to do inductive reasoning. Okay, does that make sense, the difference between the two? I hope it will somewhat make sense. I'll give you some resources to do some more research into these, and we'll do some more examples as well. Let's look at 1B here. None of the students who ride Raul's bus own a car. Okay, so this is a rule, right? None of the students who ride Raul's bus own a car. That is a rule. Ebony rides a bus to school. So Raul concludes that Ebony does not own a car. Okay, he's using deductive reasoning. He's using this rule or fact to conclude that she does not own a car. Okay, so this again would be deductive reasoning. Okay. A couple of things that we need to look at with deductive reasoning is we need to look at some specific examples of deductive reasoning. So one form of deductive reasoning is called the law of detachment. And what this says is, and hopefully you remember this from last time, so if statement P, Q is if P then Q is a true statement. So if statement P then Q is a true statement, and P is true, then Q is also true. Okay, so if the whole statement is true, if this guy's true, then then we can conclude that Q is also true. So here's an example of that, because that is just, some of these definitions can be very confusing, and they're, when you read the definition, you might be more confused than what it actually is trying to say. So here we go. Let's look at an example. It says, if a car is out of gas, then it will not start. Okay, so that's like saying this is the P statement, this is the Q statement. If a car is out of gas, then it will not start. Okay, so that's like the P then Q. Okay, if this part of the statement is actually legitimate, if it's true, then we can say that Q is true. All right, so here, It says Sarah's car is out of gas. So it's saying that P is true, right? This car is out of gas. Then a valid conclusion is that her car will not start. Okay, because we know that this part is true. That's all the law of detachment is trying to say. Okay. So that's the law of detachment. Let's look at example 2a. It says determine if the conclusion is valid. So this one says, if 3 points are non-collinear, they determine a plane. Okay? So here's the P statement, here's the Q statement. And now the yellow part is the given, right? So it says, okay, so points A, B, and C, those are 3 points, lie in plane G. Conclusion, points A, B, and C are non-collinear. Okay, so let's think about this, you guys. Okay, if we're in, let's just say we're in plane G, which is like a piece of paper, right? There's plane G. Okay, it just says A, B, and C are in the plane. Couldn't I have an A, B, C in the plane and them be collinear? Couldn't they all be on the same line? They could be, right? So notice on this one, it doesn't say anything about A, B, and C being non-collinear. So we can't determine that they make up a plane or not, because they don't tell us whether or not A, B, and C are non-collinear. Okay, so the conclusion here would be invalid, because, well, what I would say is we don't know if A, B, and C are non-collinear. Okay? So that's an example for law of detachment. That would be invalid. Let's look at 2b. If a student turns in a permission slip, then the student can go on the field trip. Okay? So here's P, here's Q. Okay, so it says Philippe turned in his permission slip. So P is true, right? This part, student turned in the permission slip. He did. So part P is true. Then we can conclude that Q is then true. So he can go on the field trip. So this would be valid because, well, we could say because P is true. And since P is true, we can use the law of detachment to conclude that Q is true. So we can just say law of detachment, since we've talked about what that is. Okay, another thing that we have to think about is law of syllogism. Okay, the law of syllogism comes up a lot in geometry. We call it different things. But this one says, if P then Q is true, and if Q then R is true, we can cut out the middle guys and say that if P is true, then R is true. That's called the law of syllogism. So an example, if you get a job, then you will earn money. If you earn money, then you will buy a car. So notice, P, Q, this is Q again, and this is R. Okay? So the valid conclusion can be that we can eliminate all of the Q's, okay, because if P then Q is true in both, and just say, if you get a job, then you will buy a car. Okay, that's what law of syllogism allows us to do. It allows us to cut out the Q if Q is repeated twice, and we know that those two things are true. Okay, so let's look at example 4. It says, which statement follows logically? In example 4, if you do not get enough sleep, then you will be tired. If you are tired, then you will not do well on the test. Okay, so F says, if you are tired, then you will not get enough sleep. Okay, that doesn't really make sense, right, with any of the logic that we've talked about. Let's look at G. If you do not get enough sleep, then you will not do well on the test. Okay, if we look at G, I'm going to circle G here, because G just used the law of syllogism. Do you notice that, you guys? It says, basically, P is true, right? then this guy, then you will be tired, and if you are tired, okay, so the being tired is the thing that doubles up, so that's the Q, right? Then you will not do well on the test. So if you do not get enough sleep, then you will not do well on the test. We can conclude that because this guy and this guy matched up. Okay, just to make sure we chose the right one, let's look at the rest of them. If you do not do well on the test, then you did not get enough sleep. Well, no, we can't go backwards. Okay, so this is an important thing to note. We can't go backwards because couldn't there be a number of other factors that allowed us to not do well on the test? What if, for instance, what if what if there was a death in your family, or maybe a pet died, or maybe something, maybe a fire goes through and you're stressed out? Then that could also affect how well you do a test. Or maybe you didn't eat breakfast, maybe something not as extreme. If you don't eat breakfast, not drinking enough water, if so there's other things that can affect the test outcome. We just know from this statement that if you don't get enough sleep, then you're not going to do well on the test. So it works in one direction, not the other direction. Okay, so G would be the correct answer. For example 5, given the midpoint divides a segment into two congruent segments, if two segments are congruent, then their measures are equal. Okay, M is the midpoint of line AB. So in example 5, what they want us to do is they want us to come up with a conclusion given this statement. The midpoint divides a segment into two congruent segments. Okay, so if we think about that, here's the midpoint. It divides this and this into two congruent segments. If two segments are congruent, then their measures are equal. So it's saying this, so this is equal to this. So it says M is the midpoint of line AB. Okay, so let's draw that. Here's M, here's A, here's B. So that's okay. So our conclusion then is this. We could say that AM is equal to MB. All right, so AM is equal to MB, and the reason we can say that is the law of syllogism. Okay, the midpoint divides the segment into two congruent segments. If two segments are congruent, then their measures are equal. So we're basically just, so they gave us this, right? The midpoint divides the segment into two congruent segments. M is the midpoint of line AB. Okay, so we can use our logic to say that this guy is equal to this guy using the law of syllogism, right? The part that is in both things is the congruence. Two segments congruent, two segments congruent. We can cut those out and just say the midpoint, if we know the midpoint and it divides the segment up, then the measures are equal. All right, so AM is equal to MB. If you guys need some more examples, there are examples on YouTube. This link will not work on the video here, but you can look up some more of these on YouTube. There's lots of them there. The homework depends on if you're looking online or if you have your actual textbook. Please do see the directions for that. And there should be a homework sheet posted. All right, I will catch you guys next time. Please feel free to shoot me any questions.